This video is on the objective complete the steps of a two-mean hypothesis test. This is with two dependent samples, right, with the paired data. And remember, when you have the paired data, we're going to end up taking two samples and turning it into one sample of differences, and then really doing a test about one mean, right, the mean of those differences. So when it says two mean hypothesis test, it's really going to end up being a one mean hypothesis test about the mean of the differences between these dependent samples. And this is with the p-value approach. Alright, so if you want to see how they're doing things, how they're instructing you, click on More Instruction. Look at their notes, their examples, their videos, and hopefully those help you out. Alright, so here we have Tucker, a manager of radio station B, and Christina, a manager of radio station A. They had an argument recently about which radio station had higher ratings. He wanted to show Christina that the ratings for radio station B are superior, or higher, than those of radio station A. Tucker randomly selected 7 time slots and recorded the ratings of each station for each time slot. The results, in points out of 15, are shown in the table below. And later when we take differences, right, because again, these are related to the same time slot, so these are dependent samples, these are paired data. I can't switch the 14.1 and the 10.8 here because, again, each pair of data is related to one time slot. And when we take differences, eventually, they want us to take the differences in ratings for radio station A minus the rating for radio station B. Alright, so we're asked to assume that both of the populations are normally distributed. Alright, so that way when we look at the mean of the differences, d bars, right, the d bar distribution will be a student's t-distribution with 6 degrees of freedom, right? Because I'll have 7 differences. And remember, the number of degrees of freedom was the sample size minus 1 for our single student's t-distribution. Okay, and then it says, is there sufficient evidence at alpha equals 0.05, so there's the significance level, to show that radio station B has higher ratings than radio station A, like Tucker claims. Alright, so I'm going to establish some stuff here. Let's get rid of the calculator for now. I'll come back to it. So the differences we're taking here are, again, the radio station A, let's say the A ratings, minus the radio station B ratings. Alright. And we're going to eventually make a claim and set up hypotheses involving mu D. Mu sub D is the population mean difference. The population mean difference between the ratings of, instead of just looking at 7 time slots, this is for all time slots in all the shows on these radio stations. The population mean difference in ratings. Let's say difference in ratings, between radio station A and radio station B. Now the claim that we're testing here, right? What they're asking us, they're saying, is there sufficient evidence at alpha equals 0.05? Right, I'll write that off to the side here. The significance level alpha is 0.05. To show that the radio station B has higher ratings than A. The claim is that station B has higher ratings. That's what we're testing. Well, to put this in terms of the mu D here, if B had higher numbers than A, and I do A minus B, that means this difference is going to be negative most of the time, according to this claim. if I take a small number minus a higher number, it's, this should be negative. So saying that B has higher ratings is the same as saying that, on average, this average difference for the whole population is negative, right? Is less than 0. Right? Again, based on the way that ratings are being taken, these differences are being taken here. All right. So then, once a claim is set up, you can establish your hypotheses, right? The null hypothesis, the alternative hypothesis. The claim does not involve equality, so that will be the alternative. The null is always the opposite of the claim, so that'd be that mu d is greater than or equal to 0. But as you've seen in most problems, we'll just be writing the equal part. What we're going to be assuming for the test. We're going to assume that mu d equals 0. In other words, we're going to assume that there is no difference in the ratings between these stations, that they have the same ratings on average, and test that against this statement here that station B has better ratings. Okay. All right, so that's what we're starting with, right? Setting up these hypotheses. So the null hypothesis, that mu d, the mean difference is equal to 0. And again, saying that, if you're doing A ratings minus B ratings and saying that the B ratings are better, you'd then be saying on average the differences are less than 0, right? So mu d is less than 0 would be that claim. Right? Okay, great. Hopefully that made sense. All right, next, I'm sure we're going to have to then find, the test statistic and stuff like that, right? So again, given that same table of data, right? We're gonna take the differences, all right, and find our test statistic. So I'm gonna do this on the calculator, all right? And you can do it by hand if you wish, but I'm gonna pull the calculator up and hit the stat button, edit, and go to those lists. And down list L1, I'm going to enter the ratings for those radio station A shows. So, 10.2, then 14.3, 6.88. Okay, and there are 7 of these, right? And I'm also going to enter down list L2. I'm going to enter the radio station B ratings for those same time slots. And I'll pop right back when I'm done with all those. Okay, so you can see I've entered now all 7 of the radio station A ratings and all 7 of the radio station B ratings. And then what we're going to do is I'm going to go to list L3 and enter the differences. Now I'm going to do, they want, radio station A ratings minus radio station B ratings. So I'm going to go up to L3, move the cursor up there, hit enter. You see the flashing, it says L3 equals. I'll take the L1 values minus the L2 values, right? The radio station A ratings minus the radio station B ratings, and hit enter. And then you see how L3 is now populated with all those differences. 10.2 minus 10.8, negative 0.6. 14.3 minus 14.1, positive 0.2, and so on. So I've got L3 is the one I'm going to focus on now. Right? It's the set of all the differences. All right, that sample of all differences between my radio station A ratings and radio station B ratings. All right, so I'm going to get out of here. And then what I want to calculate now, I'll pull the calculator back up, is for that sample of differences, I want to find what's the average of those differences, those 7 differences. What's d bar? And also, what's the standard deviation for those differences? What's SD? So I can pull that up and go, stat, over to calculate. And I'm only looking at that one list, right? The one list of differences. So I'm still using just one variable stats. And I see it's already L3 here from an earlier problem I've done. But L3, just put in that list with those differences, and there's no whatever list number you have it in, and then there's no frequency list, right? So I just go calculate, and then the X bar, that's the D bar, negative 0.76. That's the average of those differences. And then moving down, you see SXS, right? S, that's the standard deviation of these differences, which if I round to 3 decimal places would be 0.794. Right. All right, and then again, the sample size is 7, right? There are 7 of these differences. Now, because we're assuming that the population ratings for A and B are normal, these differences, these mean differences, would have a student's t distribution with 6 degrees of freedom. All right, with 6 degrees of freedom. And our test statistic is what is the t-score for our sample mean. So I take our sample mean minus the assumed population mean of the differences. Now again, this is assumed to be 0 from the null hypothesis, right? We are assuming that mu d is 0. So really I just have d bar, our sample mean, in the numerator, divided by, and then this, remember the standard error for this distribution of d bars would be the, since it's student's t, I don't know sigma, right? I don't know sigma, so I'm going to use s, right? The standard deviation of the sample as an approximate, divided by the square root of the sample size. All right, this was the formula for our test statistic for these tests about the mean of the difference in paired data. Well, let's put some values in. A d bar, negative 0.76 in the numerator, divided by, and then the standard deviation of my sample was about 0.794, divided by the square root of the sample size. There were 7 of those differences. All right, and I'll round this to, now they ask us to round to the nearest hundredth, all right, for the test statistic. So I'll show you actually a couple ways of doing this. This is what the rounded version, where I can take negative 0.76 divided by, and then in parentheses, our standard deviation, rounded to 3 decimal places here is 0.794, divided by the square root of 7. All right. So our test statistic is approximately negative 2.53. All right, there's our test statistic, meaning that our sample mean, the mean of all the differences from our samples, is 2.53 standard deviations below 0, right, below the assumed population mean difference. Now another way to calculate this, and I might have shown you this in a previous video as well, is you can go to the variables area and then you see statistics at number 5. I can take the mean that I just calculated. See that this x bar is just the d bar that was just calculated, and then divide it by, and then the square, and then the standard deviation, which again I go variables, statistics, number 5, and then number 3 is the standard deviation, and that's this 0.794, but it's more accurate, it's not rounded, then divided by the square root of 7. And this will be more accurate, but you can see that they still both round to, if you round to 3 decimal places, earlier, they're probably pretty close. I mean, you see how these are the same value to 4 decimal places. So they both round to negative 2.53, right? So either way, I'm getting a test statistic of negative 2.53. Negative 2.53 is what I'm entering there. All right, and then I'm certain after this we'll be asked about the p-value. So let's continue. And yeah, they give us a table here and ask us to, the p-value falls between which of these numbers here, right? Or what special values. All right, so let me talk about this distribution with 6 degrees of freedom and our test statistic. And And I didn't mention this earlier, but hopefully you noticed. The alternative hypothesis is that, mu d is less than 0, right? That, station B has higher ratings. This would be then a left-tailed test. And remember how you calculate the p-value is dictated by what kind of a test you're running. So let me draw this distribution. All right, so I got again a t distribution with 6 degrees of freedom. So again, the horizontal axis here is a t-scores, got a symmetrical bell-shaped curve above that. The t-score under the peak is 0. Our test statistic comes in at negative 2.53. So that'll be over here somewhere. All right, there's our test statistic. And this is a left-tailed test. Right? And you can see from the alternative hypothesis. A left-tailed test. Now for the p-value in a left-tailed test, that's just the area to the left of your test statistic. So area equals p-value, right, in a one-tailed test. If it were a two-tailed test, I'd take the area to the left and then double it. All right, so I can do this with my calculator. This is the area under a t distribution. Second distributions, go to that TCDF and find the area of this region. Now there is no lower area, so I'll just put in some big negative number, say negative 99999. The upper value in this region is the test statistic, negative 2.53. The degrees of freedom was 6. Right, this is 6 degrees of freedom. I think I said that. Yeah, right there, 6 degrees of freedom. All right, so I got all that. And this area is about 0.022. The p-value is approximately 0.022. So the p-value, that's between 1 and 2.5%. Right, it's about 2.2%. So I'll probably be writing that in a second. But if you look at the table, remember our test statistic was negative 2.53. Now the table here only involves positive values. So let's take a look at what positive 2.53 does for us. And we have 6 degrees of freedom. So I'm looking at this row here with 6 degrees of freedom. Now where does 2.53 lie? Between here and here. Right, between 2.447 and 3.143. And the area to the right of 2.447 is 2.5%. The area to the right of 3.143 is 1%, and our values between those. So the area to the right of positive 2.53 would be between 1 and 2.5%, meaning that the area to the left, using the symmetry, right, the area to the left of negative 2.53 is also between 1 and 2.5%. So I'm using those values, right, 0.01 and 0.025. That's what they're asking us for here. Now I know it's more, I wrote on paper the p-value is about 0.022, which is between 1 and 2.5%. Right? We're asked to punch in values that are showing up on this table. Okay. All right, then after this, I'm sure we're going to have to make a decision about, do we reject the null hypothesis or not? And then what kind of conclusion can we make related to the claim? All right, so finally, what do we say? Okay, so remember what we do with the p-value. I can get rid of the calculator now. Alpha was 0.05. Right? The significance level was 0.05. We saw the p-value is 2.2%, or between 1% and 2.5%. So what we're seeing here is that the p-value is less than or equal, definitely less than, alpha. 2.2% is less than 5%. And if that is the case, you are going to then reject the null hypothesis. And if you look at the hypotheses, going back to this page, right, we are rejecting this statement. We're rejecting the null hypothesis that mu d was equal to 0, that there is no difference between the ratings. And if we're rejecting this, then we are accepting the alternative. And the alternative hypothesis was that claim that, station B had higher ratings. So, based on the evidence, it looks like we can say station B has higher ratings. So again, we reject the null hypothesis. So it's either this second one or this fourth one. And then, this one says that there is sufficient evidence, there is enough evidence to show that radio station B has higher ratings than station A. That's exactly what I was saying earlier. That's what we're supporting if we're rejecting the null. Wonderful. All right, and as with most of the objectives where they have you complete all the steps of some hypothesis test, if you go through slowly and surely and get all the steps right the first time, you're probably only going to have to do that one time. And then the objective will be over, as you saw here with with the confetti falling on the screen. Okay. All right. So hopefully, watching me go through this, looking at the more instruction if you need to, reading the answer explanations when they show up. Hopefully, all this stuff is helping you out when you do this material on your own. And thank you very much for watching.